Hello YouTubers, my name is Jean-Pierre but you can call me JP. In this video, I will be showing you the assembly of my rotary phase converter, which will give me 3-phase 600 volt in my home garage. So here we go. The reason I built my rotary phase converter was to power my surface grinder, which is a 5 horsepower 575 volt machine. It also draws 5 amps at 575 volt on 3-phase. This is why I'm using a 7.5 horsepower electric motor on my RPC. The current draw on the 240 volt panel box is approximately 15 to 16 amps, so this system is not too demanding for my home garage. All the knowledge needed to build this converter was gathered on the Practical Machinist forum. They have a segment just on rotary phase converters. This is mostly an American forum, so more centered around 440 volt systems. One member of the forum really helped me with the design. 600 volt is a very high voltage and very dangerous, it will kill you, it's not to be taken lightly. There are some safety measures to be taken. Ground wires must be properly done, parts must be 600 volt rated. My phase converter is connected to my 240 volts electric panel. There is also a bulk transformer which reduces voltage from 240 to 230 volt. This is to have exactly 575 volt at the outlet of my system. Finally, I have a regular 240 outlet. The 240 plug goes to a fusible safety switch with 2 fuses of 30 amps each. The breaker in my garage panel box is also a 30 amps breaker. Moving on, the 240 line goes to a 600 volt transformer, which usually reduces voltage from 600 to 240, but in this case, it's connected to get 600 from 240 volts, kind of backward. And this is always single phase. From the transformer, we go to the electric motor, which is a 3-phase 7.5 horsepower 7.5 amps 575 volts. This electric motor will be making the third phase. 3-phase electric motors can run on single-phase power under certain circumstances. The motor must already be spinning when we feed it with single phase. So I made a system with a pony motor that will pre-spin the main electric motor before I can apply power. The start mechanism consists of a lever, a spring, a belt, a pony motor which will spin the main motor, a cam and a switch which energizes the pony motor. Once the main motor is spinning fast enough I can release the lever, apply power, and now the RPC will be working as intended. There are 3 status lights. The first one lights up when the main fusible switch is on. It comes on when the 240 volt is feeding the system. The second one lights up when the idler relay is on, meaning the 3-phase 575 volt motor is running. Finally, the third light goes on when 3-phase 575 volt is available to my outlet plug. There is a device called an ICM450 which verifies that all 3 phase are within certain parameters. These parameters are user-defined. This device enables a contactor before the outlet plug. Now I will show you the start procedure sequence. Stay tuned, as it will be quick. The first thing is to verify that we are plugged into the 240 volt outlet, then I can engage the main switch. The first light comes on. I press the lever which will make the pony motor spin. When the main idler motor is turning fast enough, I can release the lever and press the main start push button on. The second light comes on, meaning that the 575 motor is energized and working properly. Finally, the third light comes on, meaning that I have 3-phase power 575 volt available to the power outlet. To stop the RPC, all I have to do is press the stop push button. This is the outlet receptacle of my RPC. Here is the interior of the main control panel of the phase converter. Let me show you the different parts of the panel. First thing though is to verify that we are not under power. Make sure the plug is not connected. 600 volts is very dangerous. Do not work with devices that are under power. So what do we have here? Wires coming from the 600 volt transformer to a power sharing block. 3 fuses of 15 amps each to protect the 575 volt idler motor. 3 other fuses here to protect the ICM 450 device. This device verifies that the 3 phases are equal in voltage between each other. It is user-defined. I have programmed it so that the voltage must be 575 plus or minus 10 volts to energize the power outlet. So if one of the phase voltage is outside the tolerance, it de-energizes the contactor, shutting off power to the outlet. There are 2 contactors, one before the power outlet and one before the phase converter idler motor. This one also has a thermal overload safety which will cut the contactor in case of a problem. Here we have a small transformer that is 600 to 120 volts because the panel runs on 120 volts. There are also fuses to protect the different devices. Here we have capacitors, which are connected to the 575 volt lines. They are used to fine-tune the voltages. When the rotary phase converter is under load, voltage swing will happen between phases. So we try to bring back the voltages closest to 575 as much as possible when the RPC is under normal load with these capacitors. One thing that is missing here are bleed resistors on the capacitors. They are used to discharge the capacitors when the RPC is shut down. Even when the RPC is off, these capacitors are charged with 600 volt, so you could electrocute yourself if you were to touch them. To find the needed capacitance, I had my surface grinder connected to my phase converter, and I measured the voltages and current on each phase at different loads. My surface grinder has several electric motors making the load change. There is the main spindle motor, a big hydraulic pump, the head raise motor, coolant pump motor, all which change the load, whether they are on or off. The maximum current was around 5 amps. I ended up with a table containing hundreds of voltages and amps numbers, making several graphics to finally come up with the best capacitance numbers needed to operate the phase converter, with and without loads. Parce que quand j'arrête le grinder ou la machine que je veux utiliser pour le 575, il y a un débalancement sur le voltage. You may be wondering why there are so many safety devices. If there would be a power outage, the rotary phase converter idler motor would stop turning, and let's say the power comes back on, but the idler motor is not spinning. 600 volt single phase power coming in a stopped motor is not good, it would certainly burn something. So as soon as there is a power outage, the contactors disconnect to protect the system, whether it is the phase converter or the machines connected to it. I made up a drawing of the electrical system which I keep inside the cabinet. Here we can see the 2 control push button, green to energize and red to stop. When I press the foot lever to power the pony motor and I feel the idler motor is turning fast enough, I can press the green button.
Une fois que que je sens qu'il tourne à la bonne vitesse, c'est à ce moment-là que je pèse sur le bouton vert pour alimenter ce moteur-là en 575 volts. Je vais
I
vous
will show
montrer
you the
l'intérieur
transformer
du
itself.
transformateur.
Make sure the power cord is not connected because 600 volt is dangerous.
Parce que le 600 volts, c'est très dangereux. Je vous l'étudie.
This is a 6 kVA transformer,
De 6 kVA
600 to 240 volt.
avec deux
It's
bobines
single phase, with 2 windings for the 2 hot legs.
240 à
Connected to 240, it gives 600 volt. Voltage is also fine-tuned with the bulk transformer. Of course, all ground wires are connected to their proper places for security.
pour la sécurité, évidemment.
This concludes my video. If you have any requests or comments, please don't hesitate. Thank you.